Hello, everyone, and welcome back to another exciting episode of Emerge Tech AI Tool Talks. I'm your host, Mary Mayweather, and today we're diving deep into the fascinating world of AI model optimization. This episode is tailor-made for model fine-tuning and distillation enthusiasts. So, grab your headphones, settle in, and let's embark on this AI adventure together. Fine-tuning and model distillation are two techniques used to optimize pre-trained models for specific tasks or to deploy them more efficiently. While both involve adapting or compressing models, they serve different purposes and have distinct methods, pros, and cons. Model fine-tuning. Fine-tuning involves taking a pre-trained model and adapting it to a specific task by training it on task-specific data. Fine-tuning allows a model to retain the general knowledge it learned during its original training, while adapting its weights to better handle a particular task or dataset. How it works. A pre-trained model, often trained on a large general dataset, like Llama or GPT models, is used as the base. The model is then trained on a smaller, more specific dataset related to the task at hand, often with a lower learning rate to adjust the weights. The fine-tuning process updates only parts of the model, like the final layers, or all layers, depending on the task's complexity. Pros. High performance. Fine-tuning allows models to excel in specific tasks by adapting their general knowledge. Task-specific customization. Models can be fine-tuned for domain-specific tasks, e.g., medical text processing, customer service chatbots. Less data required. Compared to training from scratch, fine-tuning usually requires less data since the base model has already learned general features. Cons. Resource-intensive. Fine-tuning large models can still be resource-intensive, requiring GPUs and a significant amount of computation. Overfitting risk. If the fine-tuning dataset is too small, the model might overfit to the new task, reducing its generalizability. Storage cost. Storing multiple fine-tuned models for different tasks can increase storage requirements. Model distillation. Distillation refers to compressing a large, complex model, called the teacher model, into a smaller, simpler model, called the student model, which mimics the performance of the original model, but with fewer parameters. How it works. A large, powerful model, teacher, is first trained on a task or dataset. A smaller model, student, is trained to mimic the output, logits, of the larger model, essentially learning from the teacher's predictions, often referred to as knowledge distillation. The student model tries to approximate the teacher model's behavior, retaining much of its accuracy while requiring fewer resources. Pros. Efficiency. Distilled models are much smaller and faster, making them more suitable for deployment in resource-constrained environments, e.g., mobile or edge devices. Lower latency. The smaller model can often perform inference much faster than its teacher counterpart, improving real-time application performance. Less computational cost. Distillation reduces the number of parameters, allowing the model to run with less memory and computation power. Cons. Accuracy trade-off. The distilled model may lose some accuracy compared to the larger teacher model, especially for more complex tasks. Limited knowledge transfer. Some knowledge from the teacher model might not be fully captured by the smaller student model, leading to reduced generalization. Examples of fine-tuning and distillation for popular model families. 1. Llama models. Meta. Fine-tuning. Llama models can be fine-tuned using domain-specific datasets, like biomedical datasets or customer service queries. Fine-tuning techniques include using task-specific objectives and datasets for natural language understanding tasks. Distillation. Smaller versions of Llama models can be trained to mimic the performance of the larger Llama models, enabling deployment on resource-limited systems while retaining reasonable accuracy. Tools like Hugging Face's transformers support the distillation of models. 2. GPT family, OpenAI. Fine-tuning. OpenAI's GPT models, GPT-3 and GPT-4, can be fine-tuned for specialized tasks using APIs. For example, fine-tuning GPT-3 on domain-specific tasks like legal document summarization or chatbots involves feeding it a specific dataset to adapt its knowledge. Distillation. Techniques like TinyBERT or Distill GPT-2 can be used to distill GPT models. OpenAI allows developers to fine-tune and distill their own GPT models through third-party tools like Hugging Face. 3. T5, Google. Fine-tuning. Google's T5 model can be fine-tuned on different tasks like summarization, translation, and question answering using datasets like Squad or CNN Daily Mail. Fine-tuning T5 can involve freezing certain layers or the encoder, while updating the decoder for task-specific requirements. Distillation. T5 models can be distilled into smaller versions, e.g., T5 Small or T5 Base, to be deployed more efficiently while retaining a high degree of task performance. Distillation methods like KD, knowledge distillation, can be applied here. 4. BERT family, Google, Meta. Fine-tuning. BERT models, like BERT Roberta, are frequently fine-tuned for specific NLP tasks such as named entity recognition, NER, classification, or summarization tasks. Fine-tuning BERT can involve updating all layers or just task-specific heads. Distillation. DistillBERT is a well-known distilled version of BERT, which retains around 97% of the performance of the original BERT model, but is 60% smaller and faster. Leading tools and techniques for fine-tuning and distillation. Fine-tuning tools. 1. Hugging Face transformers. Hugging Face provides an easy-to-use interface for fine-tuning a wide range of models, Llama, GPT, BERT, T5, for specific NLP tasks. Supports task-specific fine-tuning, e.g., summarization, classification. Fine-tuning with transfer learning. 2. LoRA, low-rank adaptation. This technique is used for fine-tuning large models by updating a small number of low-rank matrices. It helps reduce the computational burden of fine-tuning massive models. 3. DeepSpeed. Developed by Microsoft, DeepSpeed is designed to efficiently fine-tune and train large-scale models. It provides memory optimization and can handle extremely large models with fewer resources. 4. Colossal AI. Provides efficient and scalable solutions for fine-tuning large models, making it easier to deploy models in a distributed manner while reducing resource requirements. Distillation tools and techniques. 1. Hugging Face distillation. Toolkit. Hugging Face offers pre-built pipelines for knowledge distillation for models like BERT and GPT, supporting tasks like text classification and question answering. 2. DistillBERT and TinyBERT. These are distilled versions of BERT and are often used as baselines for model distillation in NLP tasks. They are smaller and faster while retaining most of the original model's accuracy. 3. TinyBERT. A specialized technique for distilling BERT into a much smaller model, fine-tuned for specific tasks like sentiment analysis, NER, and more. 4. TensorFlow model optimization. Toolkit. TensorFlow provides a toolkit that includes quantization and distillation techniques for reducing the size of models while maintaining accuracy. This is useful for deploying models on mobile or edge devices. 5. OpenAI's smaller GPT variants. OpenAI has produced smaller, distilled versions of its GPT models for cases where developers need lightweight versions of GPT for specific applications, using techniques like quantization and distillation. Summary. Fine-tuning excels in task-specific customization and performance, but is resource-intensive and may require significant data and compute resources. Distillation offers a lightweight, efficient way to deploy models by compressing them, but may lose some accuracy compared to the original large models. Popular model families, like Llama, GPT, T5, BERT, have robust support for both fine-tuning and distillation, with dedicated tools like Hugging Face and Deep Speed, making it easier for developers to implement these techniques. Stay tuned for our next episode, where we'll continue to explore the cutting-edge tools and technologies shaping the future of AI. Until then, keep innovating and pushing the boundaries of what's possible. I'm Mary Mayweather signing off.